Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 10-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to understand some of the key features of cube root functions. So a cube root is a function noted like this. See the little tiny 3 here where the index goes, all right? A cube root is essentially asking what number times itself 3 times will create the number here in the radicand. All right, so for example, if I take the number 2 and I multiply it 3 times, I would get 8. So I would say the cube root of 8 is 2. The same thing with 8 and -2, or -1 and 1. Okay? Now the cube root function does look a whole lot like the square root function. Like you can kind of see the square root swoop here. But the thing is that cube roots, if you have a negative number can come out as your output. So you also get this kind of downward swoop where it rotates around the origin. Now understand that x cubed is equal 0 only when x equals 0. The origin is the only point on the graph where the function intercepts both the x and the y axis. All right, so the cube root of 0 is 0, so there it is, your x and your y intercept. Of course, those intercepts will change if you translate the graph, right? So if you move the graph up, down, left, or right, of course that intersection point is going to change. Now notice, as the value of x increases, so as we move to the right of the graph, so does its cube root. So the cube root function is always increasing. And that kind of throws kids off because it's like, oh, here it's in the negatives. But yep, it still has a positive slope right here, doesn't it? Positive slope, positive slope, positive slope, positive slope, positive slope, all the way up. Now, there aren't any restrictions on the x or y values. So if we're talking about the domain and the range, the domain describes the x's. Notice that the graph goes forever to the left and forever to the right. So we would say that the domain is all real numbers because it continues forever in both directions. Now, kids tend to get a little confused on the range. The range is talking about the y values. Notice this graph does continue in a downward trend for forever and in an upward trend. It's just very slow. So, because it goes down for forever and it goes up for forever, the range is also all real numbers. All right, so then it asks about a minimum and a maximum value. Now, that's kind of tricky because this S shape, I just said, goes down for forever and it goes up for forever. So there isn't a minimum or a maximum for the function unless you restrict the domain. So if you say, hey, I'm only going to consider the function from, say, -8 to +8. Well, then you do have a minimum or a maximum within that section. All right, so this one wants us to talk about from -8 to 8. So what we're going to do is we're going to cut out a piece of the graph. Right? These dotted lines generally mean cutting, right? If you're doing a little worksheet. So if we cut out or take a snippet of just this blue part of the graph, they're wondering what the smallest x or smallest y value and the biggest y values are. We just discussed that the function's always increasing. So the lowest part of the graph is going to be furthest to the left, and the highest part of the graph is going to be furthest to the right. So if I plug in the -8 and the +8 into the function, I should get the values that is showing on the graph here. All right, so if I take the cube root of -8, I get -2. And so that's where this ordered pair is coming from. If I take the cube root of +8, I get a +2. And that gives me my maximum there for my y value. Now understand those minimum or maximum only work when you cut out an interval of the graph. If you don't restrict that domain, there is no minimum, there is no maximum. All right, now to try it, I'm going to do it very similar to what I did with the yellow here. I'm just going to plug these values into the function. So the furthest left value is the negative 27 here. And so that's going to produce my minimum. So the cube root of negative 27 is negative 3. So that's a minimum of negative 3. The furthest right value will produce my maximum. So this tells me that the furthest right value is 27. And the cube root of 27 is a positive 3. So I would say the maximum is positive 3. Now another and final thing that I want to note. Do you see how the right-hand side of the graph and the left-hand side of the graph, they're producing the same values? It's just when you flip the sign, it flips the value. So there's this symmetry between the left-hand side of the graph and the right-hand side of the graph. It's just that symmetry is around what I call the Orion's belt, which is these 3 middle points. But there we have it. There's some of our key features of the cube root function. Until next time.